I live in the lower reaches of the Yellow River Plain, where there are many power transmission towers. I often see birds nesting on these towers. I was curious whether this posed a danger to them. After researching, the answer is yes, especially for a rare migratory bird, the Oriental white stork. With only around 9,000 individuals in the world, these storks often fall victim to electric shocks or collisions with towers. Additionally, bird droppings frequently cause short circuits in the power system. The Yellow River Delta is an important stopover for storks during migration. I'm not an ornithologist, but I'm studying artificial intelligence large language models, and I wondered if AI could become an expert to help design products that enables birds and power systems to coexist harmoniously. The first step was to fine-tune the large language model. I gathered over 1,200 pieces of knowledge on the protection of Oriental white storks from published literature and observation records into a question and answer format. I chose the Llama 3 model and pre-trained it on the Collab platform. Through training, we can test the results, such as asking what was the utilization and set selection of a Oriental white stork nest in the Yellow River Delta. It would answer that the utilization rate is 0.92, mainly distributed in the tidal zone, adjacent coastal zone, with some small number in the reed marshes and so on. However, text isn't sufficient for designing a nest, so I developed an algorithm to visualize it. By inputting the answer, key information such as bird weight, the landing speed on the nest, etc., a false point cloud can be generated in Jupyter Notebook. By adjusting sliders to set parameters such as the diameter and height, the points update accordingly. Finally, using the Delaunay triangulation algorithm, the points are connected into surfaces. At this stage, we can clearly see the main stress areas and directions, which prepare us for the next step, generative design. In this phase, I used the stress surface model to sketch the load-bearing areas. Starting with a bowl-shaped basic structure, I generated multiple nest designs. By evaluating factors like materials volume and stress, the optimal solutions were selected. I then visited the Yellow River Delta Ecological Protection Committee to seek advice and collaboration. After explaining my design, they expressed great interest and shared me crucial information on stock protection, bird data, and nest parameters. They also raised concerns about the nest structural integrity and its ability to withstand wind in natural conditions. After that, I improved the generative model. To simplify manufacturing, I designed the nest using 3 identical modulars. I also incorporated support structures and a hollowed-out curve to minimize materials usage. I aim to minimize the artificial appearance while ensuring it was as natural as possible to appeal to the birds. For wind resistance, I conducted a wind force analysis using ANSYS Fluent. Next, I visited the conservation area again to discuss the nest design with the staff. I observed how the artificial nests were being utilized. Moving forward, I will continue working with the conservation area, deploying the large language model locally to guide the protection of more bird species. Additionally, I will assist in the production of the nest locally. Watching the migratory birds fly by, I feel that when the birds use the nest for breeding, the small efforts I've made will mark the beginning of something meaningful.